We're looking into intersection of sets over here now. So we have the definition as intersection of set A and B is a set of all elements which are, yes, common to both A and B. So the keyword here is common. Using symbols, we represent it as inverted U. As an example, we have A intersecting B is the common elements are 1, 2 is not there, then 3. So we have 1 and 3. Okay. As a Venn diagram, we have the same example. So which region will represent our intersection? Yes, this one, right? So the region that is common between A and B is this particular region. So we can see over here we have 1 and 3 as well at the top. Can you see that? So that's the element related to this particular region. So we have the same answer as well over here. So to put it as a set builder form, we have A intersecting B to be made up of X such that X will belong to A and X will belong to B. So what is the keyword over here? And. Right, and operation. So you learn something called as logical gates. If you do, it is to do with and. Okay, so present in this and that. Some properties that are related to, not union, sorry, intersection. So we'll start off with commutative law. So we have A intersecting B to be same as B intersecting A. So I don't need to explain much, you guys know this. Associative law. So we have A intersecting B intersecting C to be same as A intersecting B intersecting C. So the main funda here is the order in which you are integrating them, right? Not integrating them, taking the commonality. So order will not matter, we'll end up with the same result. For example, A intersecting B, we already know that it's made up of 1 and 3. Intersecting C will give us what? So we have between C and this set, we have 1 to be the common element. When it comes to B intersecting C, we have 1 and 8. So A intersecting 1 and 8. So what is common between set A and 1 and 8? It's 1, right? Is it not? So there's no 8 in set A, so we have 1. So you can see that these two result in the same thing. Now, A intersection with a null set, the law of null set. What is common between a given set and nothing? Nothing. Is it not? Then A intersecting universal set. Yeah. So we have the universal set and we have the set A. So what is common between these two? Yes, the set A itself. Is it not? Does it make sense? Set A itself is the common factor between a given set A and the universal set. Right? Does it make sense? So it's A itself. Then this is your A intersecting A will give us what? What is common between a element and itself? A itself. Right? Again, there's no repetition, so we will end up with A itself. Okay, next thing is distributive law. So this is the new concept that we are going to introduce over here. Of course, distributive law, you've seen it with addition, subtraction, multiplication, division and all of that. So we have been using that in our lower grades. So now we are looking with respect to distributive law. So A intersecting B union C will be A intersecting B union with A intersecting C. So what is that we are distributing? We are distributing A intersection with both B and C, and the union is taken post that. So let me explain it with something like this. So we have 1, 2, and 3. Okay, I think, yeah. So let me analyze first thing first. A union, not A, sorry, B union C. So the first diagram is dedicated towards that. B union C would be, this is B union C. Agree? This result is to be intersected with A. So which region is this? So A is this. So the common region would be 1, 2, 3. So let me undo this. Okay, so that would be your result of A intersecting B union C. Over here we have A intersection B, and here we have A intersection C. So let's look into this. So we have A and B over here. The common region is this. Between A and C, the common region would be this two. Now union of this, that is combining, what will we end up with? We can see we'll end up with the same result. So these two are, the union between them will give us the same answer. Agree? So that would be your distributive law. So I guess you guys can copy from here. And I have summarized all of this over here.